Today's lesson is proportions and similar figures. Our objectives today are to find missing measures of similar figures and to use similar figures when measuring indirectly. Like saying measuring indirectly, like you want to see how tall that tree is, you take how tall you are and how long your shadow is compared to the shadow of the tree you're trying to find the height of, and you can find out how tall something is. So our similar figures have the same shape, but not necessarily the same size. So the triangles will have the same shape of a triangle. Just it might be the triangle might be twice as big or 1/3 as big as the others, but it will have the same angle degree. So it cannot change the degree of angles, but it can change the shape of the sides. But if it's twice as big on one side, it has to be twice as big on all the sides. It cannot be like all different sides. They have changed differently. They all have to change the same amount. So that's what dilation is. It's a transformation in which a figure and its images are similar. So the scale factor is how big or how small it went from the original factor. A scale drawing, it is an enlarged or reduced drawing that is similar to an actual object or place. So the main thing that we see the most about that is when we go, when an architect takes our house drawing before it's even built and draws it to not scale because, wow, that's a big house, piece of paper, but it gives us the plans to how our house is going to be built and gives us the measures of how big our rooms are going to be or how small our rooms are going to be. And the ratio of a distance in the drawing to corresponding actual distance is the scale of the drawing. So some of the stuff that we use for that kind of stuff would be like for maps and stuff. So let's look at some information we need to do. Is the information that I forgot to put on there. So I'm going to put it on pause and I'm going to give you some information I would like you to put on here. So here's the information. Triangle ABC is similar to DEF. And B is triangle AEB is similar to triangle CED. So this is the information they'll give you. So what we're going to do with it is we're going to compare corresponding sides and angles. Now we're going to do the angles first because they're the easiest of the corresponding similarities. So angles, again, like I mentioned before, they're always going to be congruent to each other. So we're going to do congruence. We're going to write the congruent sign. Now, if you don't know what that is, that looks like a little squiggly similar sign with an equal sign underneath it. So using the information they gave us above, with angle triangle ABC is similar to DEF, they gave it to us in the order that they are going to be similar. So if I look at it, I'm going to put this little angle sign. Angle A is congruent to angle D. They put them in the order that they're going to be happening. So if I look at it, angle B must be congruent to angle E. Notice how they're going in order. And angle C is congruent to angle F. So that's how it's going to correspond to each other. Now we have lines. So I have AB. Now this is where it's just similar. AB corresponds to DE. If you look, AB and DE. Next I have BC. That's BC. Is similar to EF. Now if I look, the ends of each of the sides is AC. Let's look at that. AC would be DF. So that's how you could do it for that one. So using the information I just gave you, I would like you to try B by yourself. All right. So I have angle A goes with angle C, angle E goes with angle E. I will teach you someday about the difference, why it shouldn't be written like that, but we'll go with it. Angle B is congruent to angle D, and then AE with CE, EB with ED, AB with CD. All right. Now let's look at example B, 1B. Now, we're going to find the missing length. So I notice here that CB goes with FE. So I'm going to go 7 goes with 20. Well, I don't know, but I'm talking 14 goes with something. 14 goes with this, looks like. I'm going to make that X. I don't care what variable you use. You know that. I don't care what variable you use. So I'm going to find out what X equals. So then I'm going to do my cross multiplying. We've just done these earlier. So it's going to be 20X equals 14 times 7 is 98. Divide by 20. It's 4.9. All right, I think I'm missing a number, so write this down really quickly before I go to the next picture because it's going to take everything away. All right, so here's the other one. All right, this one gave a variable. How nice of it. So X, I know, is corresponding with 6. So I'm going to put X is corresponding with 6. And 3 is corresponding with 9. So it's 9x equals 18. Divide by 9. Ooh, this one's a whole number. X equals 2. All right. Oh, no. All right, step 1 of graph the coordinates of each figure. That's step 1. So I want you to graph the coordinates of the figure. All right, so I graphed it. For you who do not remember, the first number is where it is on the left and right lane. So you find -2. And then it says up 4, so that's the reason why P is right there. So I did P, Q, R, and S, and then you're going to put your lines in between and make a quadrilateral out of it. Now that's step 1. Step 2 is to make a dilation. So step 2, dilate. Now it says half of, on this one it's half of. So it's saying that it's half of the numbers they gave you. Those are the numbers. So it's going to be P prime, that's what they're called, prime. Notice I put it's like a little prime sign. Is that little dot, and we're going to half each number. So -2, half of -2 is -1, half of 4 is 2. And then you do Q, half of 4 is 2, half of 4 is 2. R, half of 4 is 2. Half of negative 2 is negative 1. These are primes. S prime is half of negative 4 is negative 2, and half of negative 4 is negative 2. So I'm going to graph that in a different color. I would like your homework to have a different color. Mine's going to be purple. And then I'm going to graph it. So I graphed it. Now if you look, the original is the red one, and the prime one, the second one, the dilation, is half the size of the big one. That's what they mean by scale factor of half. So it's half the size of the bigger one. That's what they're saying. So let's look at B. This time we have our graph, so we're going to graph it. Graph the original point. So the original numbers are now purple. I did purple this time. Now it says the scale factor is 2. That means I'm multiplying all of these numbers by 2. So I would like you to do that for me. Stop it. Put it on pause. Double each of them and graph it for me. So I doubled them. So A prime is 6, negative 4. B prime is 6, 10. And C prime is negative 8, negative 2. You're not going to have them on your picture, but I have them on my picture so you can see it. All right, so this one's a little different. So, indirect measurement. A tree casts a shadow 7.5 feet long. So this one is 7.5 feet long. The smaller tree is 5 feet and the shadow is 3 feet. How do I do I'm going to try to find a proportion to figure out how tall the tree is. I'm going to make that an X. How tall is the bigger tree? So again, the height of the trees are proportionate to each other, so I'm going to have 5 over X. Because the smaller tree, the height is proportionate to the bigger tree. And the shadows are proportionate to each other. And then you do your math. So you do 3x equals 5 times 7.5. And that's 37.5. And then divide by 3. And that is 12.5 feet. Okay. Again, a tree casts a shadow. Hold on. A tree casts a 26-foot shadow. A boy standing nearby casts a 12-foot shadow. So the tree does a 26-foot shadow to the 12-foot shadow of the boy. How tall is the tree? We don't know. The boy is 4.5. Again, you do 12x equals 26 times 4.5. Is 117. Divide by 12. And the tree is 9.75 feet. Okay. I need to add some more information to this. Okay. The scale of a map is 1